All right, so as Todd alluded to, these are what we're going to talk through. We're going to talk through the standard plans. But really, if I'm going out in the field to do a project or I'm going to start something, if I can only take 4 sheets of paper, these right here are what I'm going to take. Okay, these are our standards. There are requirements, and you know, one of the main questions that we get, especially from some of the local government units, is, well, what do we have to do, and what's the difference between that and MnDOT? And so one of the key things here is that this is color coded. So the blue on here is the ProWAGs. Okay, those are the numbers that we have to hit. Those come out of the ADA, and so those are our maximums and minimums. Okay, part of this is remember that those are maximums and minimums. Okay, we don't have deviations from those maximums and minimums. We need to hit those. So that's why MnDOT has the standards. I mean, that is the majority of the reasons for those, is that there's constructability issues, and that's why we have these yellow numbers that are the standards. So that way when we're doing construction, we can hit those maximums and minimums on here. So there's also the MUTCD, so those are going to mostly apply to the APS systems, which will be the next module that we'll talk through. But again, there's a lot of things that, you know, everybody, okay, and my boss even questioned me. He goes, man, you guys are always changing the rules on ADA. And I said, no. I took a deep breath and just sat back for a minute, and I said, no, we haven't. I said, the rules for ADA have been in effect since 1990. So we just have been doing a bad job of hitting those rules for the last 28 years. So, you know, we just need to sometimes step back and think about what we're doing as far as that. But if you've got questions as we're going through here today, stop me. We'll ask the question. If it's just a brief one, I'll just repeat it back, so that way it's in here, and then we'll go through. And also, if we don't do a good job of saying what the acronyms are, we especially do that a lot. So we've been giving this training both to MnDOT folks and to locals. Sometimes we use that MnDOT jargon that they're used to hearing, and if something doesn't make sense, stop me. The first time Todd was talking through something, and I sat there for 10 minutes in the back of the room going, what is he talking about? And then I finally figured it out. So don't be embarrassed, and sometimes just say, okay, Tim, back up. So a couple quick housekeeping things too is that, so the plan for today, we just talked through the importance. We're going to talk through standard plans for the next 2 hours. We will take a break halfway in between there, so don't get too nervous that we're going to sit here for 2 hours straight. And then we'll wrap up the morning with APS. And that usually takes us right till about 12:15, 12:20. We've got lunch right here, so we'll take a half an hour for lunch. And then we come back and we talk through outside-in design, case studies, and then wrapping it up with scoping. We've been consistently going to 4:20 to 4:35 as far as the end time of the class. So if you were hoping to get out of here at 4:20, I just thought I'd crush your hopes and dreams right up front. So I know how sometimes when you go to trainings, it's like, oh yeah, we'll for sure get out of there early. And this is our 18th time doing it, and we've been right at that mark. So next couple hours, we're going to talk through ProWAG and curb ramp basics, the curb ramp types, and then those standard plans. So in 2010, MnDOT implemented ProWAG. ProWAG stands for the Public Rights-of-Way Accessibility Guidelines. Anybody here read ProWAG? One? Anybody have trouble sleeping at night? So 64-page document. There's a link to it on MnDOT's website. So everything that we're going to talk through today is also on our ADA website. So if you go to MnDOT A to Z, click on the ADA construction, there's a whole website there. There's links to ProWAG, there's links to the standard plans, there's the CAD files, the DGN files for those standard plans. These presentations are on there. The webinars will be uploaded there soon too. So all of this information, it's a really good resource guide that if you've got questions on it, go to that website. But ProWAG is there also, and ProWAG is really the foundation for what we're going to talk through this morning and today. But If you've got questions on the why, sometimes there's also the answers on this sheet here on these four. We talk through the standards, and then there's the answer of why we do some of those standards. But if you need further explanation, ProWag is a good resource to do. Now in ProWag, it also talks about this 4-foot wide pedestrian access route. We have to have that 4-foot par with a maximum cross slope of 2%. Okay, maximum cross slope of 2%. So ideally, we're shooting for 1 to 1.5% on all of our cross slopes on our sidewalks. But also with that 4-foot minimum par, there's a minimum passing area, a 5x5 area every 200 feet. Okay, so MnDOT's implemented the 5-foot wide sidewalk as our standard. A couple reasons. Let's think through the practicality of this, okay? So I'm here in a wheelchair. Todd's down there 300 feet away. Hey Todd, you stop at that area down there and then we can pass. Okay? Not a lot of practicality behind that. Okay? The other part is I don't know how many of you guys go out and walk down a sidewalk. Okay? I love my wife. We'll walk down the sidewalk, but if we're walking down a 4-foot sidewalk, that's a little tight. And think about it from a perspective, we do a lot of field walks. If we're walking down a 4-foot sidewalk, everybody's staggered as you're walking up and down that sidewalk. If you're on a 5-foot sidewalk, you're walking shoulder to shoulder going up and down this. So there's a number of these standards too that they're great for ADA. They're also great just from a pedestrian overall usability of this system. And we'll point some of those things out as we go through today too. Also, we've got the vertical discontinuity of a 1/4 inch. Or we can bevel it up at a 1 to 2, up to a 1/2 inch offset there. Also, we've got our longitudinal slopes. If those exceed 5%, or there's a change in direction, then we have to have a landing. And those maximum ramp slopes are 8.3%, and that's a 1 to 12, and that's a max, okay? There's not a deviation of, oh, can I go to 8.5, 8.3. So when we're setting our standards, we're going for our maximum ramp slope on our design. We're shooting for 7 to 7.5% as far as what that maximum ramp slope is in design. So that way then we've got some construction tolerance out in the field. That maximum ramp length for the initial ramp is 15 feet, and those slopes and dimensions are now absolute. So there's no variations from that. So this was the standard plate from 2004. This was a standard plate that I started utilizing in my career. I'm sure that we all built a lot of plan sets utilizing this standard plate. We went along and we had our road corridor, right? And we had our street laid out there, and we got to the intersection. We said, build a ped ramp. We put a note, and we moved on to the next section of road. In this standard plan, all of our ramps were based off of our lengths. So if we had a 6-inch curb height, we had a 6-foot ramp. And actually the ramp was 5 foot 4 inches because we included the 8 inches from the curb and gutter from the back of the curb too. So that works for a 1 to 12 in a perfectly flat world. Does anybody here design intersections in a perfectly flat world? No. There's a few places out in western Minnesota that get pretty flat, and they don't even have some of these flat intersections. So it doesn't work. It's not practical. And also on here, we had the desirable 4x4 relatively flat landing. Okay? There's nothing in there that says that that landing area is desirable. It's required. We have to have that landing area. So essentially what I'm telling you here, and when we built ramps like this, so MnDOT went out there and did our inventory on everything. When we looked at just the running slope and the cross slope on the ramp, just those criteria. Okay, we exceeded those maximums on 50% of our ramps. Okay, just on those two criteria. You know, and essentially, again, this is just what we were building. We built these for years, and the majority of them are non-compliant. So in 2011, we changed this detail sheet, and we built all of our ramps. And all of this is switching to, it's based on the ProWag, and the ramps are now based on the grades. So we're now working off of those ProWag maximums and minimums, and we required that we have that 4x4 relatively flat landing at the top of those ramps. So this is where we started to go as far as our progression. Now, The other part is that we started off with, like I said, we put our roadway in there, we put a note and said, build a ped ramp. Then in 2011, we started to get into this, 2012. And construction folks went from, we just had a note, to design and detail everything out for me, okay? And we ended up with quadrants that we had 20 or 30 elevations given on the plan sets for each quadrant of the intersection, okay? How many folks in here have done surveys? Few? How many of those people have pounded in 20 or 30 hubs for elevations on a quadrant? Nobody. Contractor would laugh us out of the room, right? Plus, I mean, and the other part of it is we were designing those 20 or 30 grade points off from aerial LiDAR, plus or minus 6-inch data that we were getting inputs on, and we're designing all the way through here. The other part, and actually if you watch some of the slides here today, you're going to see a number of examples where we go too far, okay? We've got elevations that are out to the 1,000th of a decimal point, okay? There's horizontal coordinates that are out to the 10,000th of a decimal point. You know, so essentially we went from nothing to all of a sudden we're giving every detail all the way down, because that's what we are, engineers, right? We all like to sit in our offices and pound out the numbers and make sure they all work. And then we put them onto those plans and we send it out the door. But we realized that that information wasn't working well either. It was too detailed, it was too much for a contractor, it was too much for the construction folks. And so really we've kind of settled back into the middle point of this. So we went from nothing to too much to now what we're doing is on our quadrants, on our ramps, we're giving the contractor 2 to 3 elevations and locations on those ramps. And we're telling them our ramp slopes are either steep or flat. So that's the S's or the F's. So the S slopes are going to be everything between 5 and 8.3%. The flat slopes are everything between 2 and 5%. So the distinction in there is that 5% cutoff range, and that also goes back to ProWay, because when we exceed 5%, we're in that steep ramp, then we have to have a landing at the top of that ramp. So now we're detailing our plans out, we still lay out the elevations, we make sure that they're going to work, but then we're labeling those ramps as steeps or F's, so that way then construction has a little bit of float to work with. We're telling them our intention, but we're not detailing out every last number all the way around that quadrant. A couple other key things on here is going to be the landing. So we're going to talk through this morning about how the grade breaks all work with the landing, but the landings are the key point in getting these ramps constructed correctly also. When you get those right, chances are you're going to get your ramp right. So clearly denoting where those landings need to be, and then also curb heights. So curb heights also make a big difference when we're building some of our tapers, when we've got sidewalk at back of curb, and then also where we've got to make sure that we have the proper tapers built in there, we've got our ramps constructed right, but also that we don't end up with inverse grade going into our intersection or into those ramps. So those are the 4 key points that now we're putting in and utilizing this standard legend. And again, this standard legend, and it's actually much longer than this, but these are the 4 key components on it. This is on MnDOT's ADA website also too. There's a DGN file that talks about what's all going, that gives you all of those symbols. So here's our curb ramp types, okay? And if we took these 2, the directional ramps, and I slid them right underneath our perpendicular ramps, this list on the left-hand side is my priority list, okay? So if I can build these ramps, I'm going to build perpendiculars, directionals, then I'm going to get into my fans and my depressed corners, and at the very bottom of the list is my diagonal ramps, okay? This is my priority list. So on my second ADA project that I did with MnDOT, I went out into the field, we did a constructability field walk, and we were walking through it, and we got to the first area, and Harvey from the ADA office looks at it and he goes, "Tim, you've got this too flat." I laughed because that's kind of how I handle situations, and Harvey's a little bit more stoic. He didn't find it as funny as I did. But I said, "This is ADA. It's supposed to be flat. And we proceeded to have a long conversation about, it's not just about being flat, it's about being sustainable and being maintainable. And that's something that we've really come to see and to evolve about over the last 5 or 6 years here too, is that, we've got projects, we're going to be putting down this concrete, and when we put this concrete down on the ground, how long is that concrete going to be there for? 30, 40, 50, 80 years? I mean, how often do you have concrete that you've seen that's been there for 80 years? Okay? And when we put that concrete down there, it's going to be there for a long time. So we want to make sure that we get it right. We want to make sure that it's sustainable so that way it's there for a long time. And we want to make sure that it's maintainable. Because if it's not maintainable, then we've just built a system that's going to be snow and ice prone. It's going to be hard to maintain, which then if we've got snow and ice built up in these systems, then they're not usable for what? 5 months out of the year? So big chunk of time that we're taking out of these things if we're not making sure that they're maintainable. And I also think that if we think that we're going to come back here in 15 or 20 years and we'll fix it right the next time, we'll get it then. You guys have all helped or put together your capital improvement plans, right? And how often are you coming back and milling and overlaying your roads? Every 20 years? That's what you want to do? Do you have enough money in your budget to take care of all of your roads every 20 years? I haven't seen anybody in all the presentations go, yeah, we got all the money to take care of everything in every 20 years. So chances are we're even going to be stretching those limits out further. So these projects are going to have to be there longer and longer between now when we're constructing it and when we're going to be back there to fix it the next time. So in the afternoon we're going to talk through a lot of things that we can do as far as some little improvements to these intersections and these ramps that are going to make a big difference to be sustainable and maintainable as we're going forward. So this is our priority list. So that's why if we can, we always want to build our directionals, our perpendiculars, our directionals, and then we proceed down the list. So we'll talk through these in each one. Perpendicular ramps, these are the easiest to build. You've got a nice tangent piece of curb and gutter. Your curb line is your ramp is going to come right down here in a perpendicular direction, and you're meeting that curb line. Okay, we've got a perfectly nice even ramp. We've got a landing shown on here. Now if this sidewalk is coming in, it's less than 5%. We don't have a change in direction on this particular example. You wouldn't have to have a landing. However, I would highly encourage that we make sure that this initial ramp in here is a steep ramp. So that way we're up and out of that gutter line, keeping that, maintaining that flow line in that gutter line and not up into our ped ramp. And then you have your landing and then you take off with your nice sidewalk from there. The next one is going to be a tiered perpendicular ramp. So tiered perpendicular is the same situation. The only difference is that we've got a very narrow boulevard. So when you've got a 3-4 foot wide boulevard, you've got enough distance in there to get a ramp, but you're not going to get your landing up to your full sidewalk height. So then what we're going to do is we're going to have this landing up here, right there, and then we're going to have flat slopes coming in from both directions. Okay? And we don't want to have steep slopes coming in on our secondary ramps. Okay? 2 reasons is that we always want to make sure that our sidewalk profile is less than 5% unless our roadway slope is greater than 5%. The other part of this is, let's just think about it from a practical standpoint. Okay? I'm walking down my sidewalk. If I'm just going in a straight direction, do I really want to go down 8% for 5 feet to then come back up 8% at the other side of the landing? It's going to be very awkward to be walking up and down that sidewalk. So having those as flat slopes is not only going to be more maintainable, but it's going to be a lot easier to use. The other part is if those are steep ramps, if you do exceed that 5%, then you've got to have a secondary landing at the top of those. So then you're building your initial landing plus a secondary landing if you have steep secondary ramps. So they're showing our landing and then those F slopes and those F slopes on there. Next one is our parallel ramps. So parallel ramps are going to be utilized whenever we have sidewalk at the back of curb and our sidewalk is less than 7 feet in width. So if I have a 7-foot wide sidewalk at the back of my curb, I'm going to put in a 3-foot ramp and have a 4-foot landing behind there. But if I've got a 5-foot sidewalk or a 6-foot sidewalk at the back of the curb, I'm going to have to utilize a parallel ramp. Okay? It's basically a depressed corner. Okay? Everything from my gutter line all the way through the back of my landing is all 2% max in any direction. It's all landing area. So then with that, my initial ramps are now these first ramps coming up the sidewalk line here. And I'm wanting to make sure that those are steep ramps now because I want to get up and out of that gutter line as quickly as possible. Because this area, that landing area, is going to be prone to having ice and snow buildup in there. And doing this too, then those are steep ramps, so we've got to have a secondary landing at the top of those ramps. So that's why we've got these secondary landings hatched up here on both sides. And then also, you'll see the curb heights in here. So we're going to clearly define where our curb heights are going to be because the top back of your curb profile, the tapers on that, is going to define what your sidewalk profile is. So you've got to make sure that that taper is built to the ramp slope that you want on your sidewalk. So clearly defining where that 6-inch curb is key to making sure that these ramps are constructed right. Because if you don't do that, you're going to end up with a warp on your sidewalk on the back side of that where you're either pushing drainage back onto your ramp, or that's also a spot that if this is being cleared with a skid loader, you're going to ride up on the curb and you're going to ride on the back of the sidewalk and you're going to have a little area in between there that's not going to get cleared of snow and ice. So making sure that we have our curb heights on here on these parallel ramps is going to help make sure that they're constructed correctly. Next ones are going to be fans. So with those fans, we're always having those fans constructed with flat slopes. So everything between 2 and 5%. So a couple key reasons why is first off is under ProWag, fans are treated as blended transitions. Blended transitions need to be less than 5% slope on them. The other part of this is if I'm a user and I'm coming along my sidewalk here and I'm going to go straight across the roadway, as I come through here, I should stop on that landing and navigate that ramp in a perpendicular direction so that way if I'm in a chair, my front wheels go off and onto the ramp at the same time, going down the ramp, and then my back wheels go onto the ramp at the same time. But chances are we're just going to go straight through this section, and as you do that, you're going to end up with like that front right tire going off into the air. So I'm on 3 wheels, then ideally maybe I drop down on the other 2. But as you're going through you're going to have a potential to be on 2 wheels as you're going through this section. And especially if you're in a steep slope on a real tight radius, you've got a real potential to flip. So one of the first people that, from one of the first classes was like, oh yeah, I realized that as I was pushing my kids through on their stroller, go through those intersections and you're only on 2 wheels and you can rock them in the stroller as you're going through there. So when we've got those tight radiuses and we've got those steep slopes, you've got that potential. So we've also got a 7-foot minimum radius on the top. So that's this area right through here, this grade break, 7-foot minimum radius, okay? Part of that is the majority of that is a constructability issue, okay? We've tried to construct them with tighter radiuses in there, 3-foot, 5-foot radius on the top of it. Contractors will the suppliers will give us the truncated domes for it. But when you try and put on a slope surface and get those domes in there as you're going around that tight curve, it's extremely difficult to do. I'm going to show you an example that we tried on one of our projects. And it took us a couple times to pour it to get it right. And it's one of the examples of why we have this 7-foot minimum as a standard now at MnDOT. The other part is that if you have a tighter grade break, again, it's very easy for somebody to not navigate and turn that wheelchair and navigate that ramp in a perpendicular direction. So we want to make sure that we have that as more of a gradual radius at that top grade break. So they're showing our landing and then those slopes. The next one is going to be a modified fan. So it's the same as the fan. The only difference is that if this was a fan, our grade breaks would be right here. And we've pushed those grade breaks up in both directions, so that way we can get our 4x4 landing in there. Okay, if my grade breaks were in line with the back of the sidewalk, I wouldn't have enough room to get my 4x4 landing in there. So this modified fan pushes it back. It's a good tool to utilize when you've got a really tight right-of-way constraint. When you don't have a lot of room between this pinch point on your corner and your curb line, all you need is 7 feet in there and you can make that work. You can get your 3-foot ramp in there with your 4-foot landing at the back of it. Okay, it's a good tool to utilize on those tight corners. And we're going to talk about a lot of things today too of how can I widen out this corner to make it work. But ideally, you would do some of those other modifications to have some more room, but if you can't, the modified fan is a good tool to use. Next one is our depressed corner. So depressed corners are towards the bottom of our list of where we want to what we want to utilize. And the main reason, yes. 4x4. You can do a 4x4 is the minimum required. Yep. So on our depressed corners, very similar to our parallels, the landing is everything from the back of the curve, from the gutter line back. So the gutter line back, that's all less than 2%. As far as this whole area in here, all less than 2%. Okay? Depressed corners are very prone to ice, debris, those types of things that are going, your water is just flowing right into there. They're very low on my list, but however, if I'm at a high point in my road, as far as the intersection, I got water going both directions around my returns, I'm not going to hesitate to utilize a depressed corner in that instance. Because all I've got for water coming into that depressed corner is just what's falling on that intersection and draining back towards it. So I'm not as prone to those ice and sediments when I've got that at a high point. Now, we can create a high point too, and we'll talk through some of those scenarios. We'll add a structure, maybe on one side, if there's already one on the other side, and create a new high point as we're going around there. So that way then we have that potential. We're not running water across there. If I've got a whole block coming down here, I'm not going to put a depressed corner in and run a block's worth of water around a depressed corner. That's not going to be a maintainable, sustainable solution. But when we've got to put these depressed corners in, a lot of times we're going to utilize them when we've got tight right-of-way constraints or we've got APS where we're trying to fit a lot of things in. Those types of situations, we're going to end up with some depressed corners. When we've got the depressed corners, then those initial ramps are going to be following the top back of curb profile, and those are always going to be steeps because we want to get up and out of that gutter line as quick as possible. You've got to have these secondary landings clearly defined because you've got a steep ramp here, so we're exceeding 5%, so we've got to have a secondary landing at the top of it. And again, we need to know where those curb heights are at because this curb profile along here is going to be the profile for my sidewalk. So we've got to make sure that we get those curb tapers constructed to the right slopes. The one at the very bottom of our list is going to be our diagonal ramp. Okay? And what were we building for the last 20 years? Diagonal ramps, yep. So there's a note on the diagonal ramps. Shall only be used after all other curb ramp types have been evaluated and deemed impractical. Okay? We're going to check and make sure everything else can be utilized before we're going to utilize a diagonal. So when we talk to all of our different groups, user groups that are utilizing our systems, okay, they have different priorities for how they'd like ramps constructed. Okay? There's one agreement that they all have as far as ramp types and usage. Okay? Diagonals are at the bottom. Okay, so there's total agreement that these are our last case of last resort. But we still utilize them because sometimes you need, with a diagonal ramp, we can get a few extra feet off of our ramp length, and so you can make a vertically constrained point work. So it's still a tool to utilize. It's just at the bottom of our list as far as our priorities go. And this is why. Because we're pushing all that traffic right out into the middle of the intersection. Whether it's a chair user, whether it's a visually impaired user, all those things, they're all going to end up right out in the middle of that intersection on a diagonal ramp. Next one is going to be our directional ramp. So remember, we had perpendiculars was number 1, directionals is number 2. With the directional ramps, all of this area in here, this curb line here, where note number 7 is, that's max 2% slope in any direction. So it's constructed to the same constraints as a landing, and that is poured integral with the curb and gutter. Okay, they pour the curb and gutter, they're pouring that directional curb with it. Okay, all of our contractors on MnDOT projects have been pouring this integral for a lot of years. So if any of them are giving you a hard time, saying, no, MnDOT's not making me do this, no, they are making them do it. It's all constructed that way. It helps us to end up with a better end product, that we've got a seamless, no joints along where that back of curb line would normally be.
And just to be clear, it's this 2% to the same slope as a landing, but it doesn't have to have the area requirements. The area doesn't have to be a 4x4. Basically, that just all needs to be there though, so you have a perpendicular grade break at the bottom of the ramp. So you're, like Tim was talking about, your top 2 wheels going off the top of the ramp being the same. Here, where they hit the bottom of the ramp, it needs to be perpendicular. So that's what allows, that's why we have this directional curb. Yep. So it's a flat area with a perpendicular grade break, but it doesn't have to be a 4x4.
My wheels are coming onto the ramp, my front wheels are coming onto the ramp at the same time, and they're going to come off the ramp at the same time as I'm going down this ramp. So on this previous one, when we've got a walkable, non-walkable surface along here, so non-walkable surface is going to be our grass or an aggregate surfacing, we can have that grade break, those domes set back 5 feet, okay? If we exceed that 5 feet, then we put our domes at the back of curb. When we put our domes at the back of the curb, we want to make sure that those domes fully cover the walking path, the path of travel for a pedestrian as we're going up and down here. So that's why if you look at this, there's a little bump on the back side of that walk as you're coming down here. So that way, I'm coming through this path of travel, I've got 2 foot of domes across my entire path of travel. If I just left this as a straight piece of concrete, my domes would come from here and they'd come out at an angle and I'd have a step through at that location. So that's why there's that little bump on the back of the curb as we're going through there to make sure that we have that 2 foot of continuous coverage of domes across our opening.
And part of that reason is because in Minnesota we have to use cast iron domes, and we don't really want to cut those because they're difficult to cut, they don't always seat well, and they're ragged edges, they can be sharp edges. So we have more limitations with our winter maintenance requirements of the materials that we use.
Next one is our combined directionals. So combined directional is still just that directional ramp, but we've got a combined landing. So a lot of times if you're working in a residential neighborhood where you've got nice big boulevards, you're going to end up with combined directionals or combined perpendiculars. The only difference being is that if you've got perpendiculars, you're dealing with a tangent piece of curb and gutter. If you're into the curved portion of your curb and gutter, then you're going to end up with the directional ramps. Okay. The best type of ramps that we can have, we're walking in either direction on this sidewalk, we're just walking straight across the road. We're not having any sort of change in direction for how I'm having to navigate this intersection. We've got that combined landing that we're utilizing for both ramps, and we've still got those perpendicular grade breaks, because a lot of times a visually impaired user is going to use the first 2 cues that they're going to walk to know where they're going is, one, this is the direction I've been going, I should keep on going in that direction to go across the intersection. The next one is going to be that ramp direction, the ramp is going to point me across the road as I'm going. So anytime I can give that directionality as far as a perpendicular or a directional ramp, I'm pointing that visually impaired user across the road with my ramp. Okay. We also want to make sure that this bump in the middle of the walk is not within my path of travel, because otherwise we'd be creating a trip hazard as we're going through there. So again, dome setback, if we've got a non-walkable surface, that turf or aggregate surfacing, those domes can be set back 5 feet. If it's a walkable surface, so if it's bricks, pavers, concrete, asphalt, it's all considered a walkable surface. The max setback is 2 feet on those domes from the back of the curb. So if I have, in this particular instance, I have a signal pole, a light pole, a fire hydrant right there at that intersection, I'm going to consider that a non-walkable surface. However, if that same obstruction is 15 feet back up the roadway, that's a walkable surface. That's where you've got to use a little bit of engineering judgment as far as, is there the potential for someone to be walking down that sidewalk and walk out into the road and miss those domes? So that's what we're trying to stop from happening, is making sure that there's notification that a user is going to enter the roadway. So semi-directional ramps, this is a detail that's thrown in the plan set. It's primarily utilized with APS systems in more of a rural application where we've got a large sweeping curve that's coming around here. And if we were to provide true directionality on this ramp, we would exceed our setback for our APS system. So what we're doing is we're swinging this ramp around to give it as much direction. This dashed line is going to be my path of travel. I'm trying as hard as I can to get that directionality out of those ramps, but we're going to call this our 349. So we've got a 3-foot setback on my domes from the back of my curb, right here. 3-foot setback, a 4-foot ramp, and then 2 feet to my push button on my landing. So that push button is a total of 9 feet from the back of my curb. When we look at APS criteria, the maximum that we want to be with that push button is 10 feet. So if I provided true directionality on this one, I would exceed that 10-foot setback. So it's a trick that the detail that we've been utilizing quite a few times at trying to get as much directionality as we can, but still utilizing that APS and not exceeding that 10-foot setback as we go around here. This is one instance here where we do require a walkable flare. This area here, this flare, is a concrete flare. So a lot of times on a lot of the different ramp styles that we're going to talk about, flares are up to the local city's preference, if you want a graded flare or a concrete flare. But in this particular instance, if we've got the path of travel that's going to go across those flares, then we want those to be concrete. So that way then we don't have that grass lip as far as a trip hazard going up and across there. So sheet 1, so these plan sets were revised in 2017. Yes?
So I got a question on, you went through your ramp types, and in Minneapolis, when the ball was redone recently, if anybody's been in Minneapolis doing a ball experience, the intersections, the design of the intersections actually were raised up, so there was actually no grade change as you cross the streets there. So it's the flat surface except for the ramp step. My question is, so that's kind of a little different I guess, style or type of ramp than what you're showing here. And my question for you guys is from a user experience, when I walk through it, it's pleasant because you're not walking down and up. I mean, from a being accessible, is there anything by not having those grades that might be noticed and stuff? I mean,
Yeah, so the question is basically they did a raised crosswalk, so you didn't need a curb cut anymore, so the crosswalk is at the same level as your sidewalk, your top of curb. So the sidewalk profile goes right straight through there. From a wheelchair standpoint, it's great. No up and down, just go. It actually has the traffic calming that you want because vehicles slow down for the intersection. There is definitely a drawback to visually impaired users, just because they don't feel any slope change, so they don't really know. So they're left with just the 2 foot of detectable warnings, the truncated domes, and that meets code, but it is a little bit of a drawback because if we don't have especially in winter, if we don't have our sidewalks completely cleared, the domes can fill in and lose that detection. So yes, visually impaired users have had concerns about that intersection, or that design.
Again, it's downtown Minneapolis, it's, I mean, in general, it's well maintained in that aspect, but I was just curious from a tourist point of view and stuff. So, obviously, in a rural area, you wouldn't do something like that.
Right. Yep. So I'm sure a number of you had plans submitted last year to state aid, and you probably turned them in, and all of a sudden state aid kicked them back and said, wait, you only got 5 standard sheets here for your ADA plans. You need to have the new revisions, the 2017 version. I'm sure you probably, or some of you, were actually experienced this. I had the joy of telling our CAD technician that he needed to change all the sheet numbers on the plans. That was a joyous conversation. But so a lot of the changes though, from 13 version to 17 version, there's not big wholesale changes. Okay, and a lot of people say, well, wait a second, you guys added a sheet. How did you not make wholesale changes? Well, there's a lot of these details that we're going to talk through that were added into that plan, those standard plan sheets. And there's just a few notes that were tweaked to make sure that they're more friendly for everybody to know and understand. And then there's been a couple things that, as far as construction has gone, that we've learned over the last 4 or 5 years okay, that's not our best practice. We should probably do something different for construction. So one of those key things being, we're now requiring all of our initial landings to be poured as a separate pour. We've got a ramp coming up to them. So a couple key things there that we changed due to construction, and some clarification, and then adding in some standard details that we were seeing utilized a lot around the state. The good news is that in conversations that we've been having, we're not foreseeing another plan set coming out in the near future. Now, I'll be happy to eat my share of crow pie if I need to, but that is not our anticipation right now, is that these standard plans will be here for quite a while. So I totally understood the frustration too, because I was right there with you guys of like, I turned something in and all of a sudden they're like, Tim, you only have 5, you need the 6. So, but these have been around now for a year. So we'll talk through these in detail now. So a couple notes, can't stress this enough. Landings need to be located anywhere where that pedestrian access route changes direction. So in this case here, I'm coming down my sidewalk, I've got a ramp going off to the side, that's a change in direction. I need to have a landing wherever I've got the change in direction. That may be a walk coming out from a home, that's still a change in direction for someone. We need to have a landing at that location. At the top of all those ramps, greater than 5%. So whenever we've got those ramps, those steep ramps, so that's why we have this distinction between greater than 5% and less than 5%. We go greater than 5%, we've got to have a landing at the top of those ramp slopes. And then also if our inverse grade is greater than 2%. So if we've got those tenting effects, then we need to have a landing at those locations also. So if our initial curb ramp landings need to be constructed within 15 feet of the back of the curb, ideally we want to be 4 to 6 feet back. So if I'm back here 15 feet and I'm sitting on the landing, I've got my roadway out there 15 feet away, and then I'm having to cross a 30-foot wide roadway, I've just added 50% onto my crossing distance, because I'm navigating, if I'm a chair user, I'm going to sit on the landing and I'm going to navigate that intersection from there. Now another thing is that if I'm back 15 feet, okay, put your head down where a chair user is going to be, and think about being back 15 feet from that intersection and how well can you see to make those decisions of where your traffic gaps are at. And then the other part is that where a driver is going to be looking for PEDs to be starting from too. So ideally we want those initial landings to be 4 to 6 feet from the back of the curb. The other part in here is we want to make sure that we have secondary curb ramp landings every 30 inches. So every time we're rising up 2.5 vertical feet, then we've got to have a secondary landing. So if we're chasing grade, trying to catch up to our top back of curb profile with our sidewalk, we need to have those landings every 30 inches of vertical rise, every 2.5 feet. Now once you catch your top back of curb profile, and you're going to continue on with your sidewalk profile, if your roadway is greater than 5%, your sidewalk profile is going to match that roadway profile. But it's when we're coming up and trying to catch that initial sidewalk slope, we need to have those secondary landings every 2.5 feet of vertical rise. So how long those ramps are is going to vary on if you're at 5% running slope or you're at 8% running slope on those ramps.
And the question always comes up, how far do you chase it? And in the really steep areas, you kind of have to look at it and see, like in Duluth, for example, we presented there, and you're going to have a hard time chasing it. So, you just might want to only go where you're making only 1% or 2% worse potentially. Other areas, you can chase it. So we'll go 50 feet just to make up to where we reach that 6-inch type curb height. So we'll do that. And but every situation is a little different, so you evaluate it. I mean, in some cases you might not even get a landing in because it is so steep, either secondary or even primary. Sometimes the initial landing you don't get that in. But you really have to evaluate these areas individually for how your tie-ins are going to work. Basically just chase your slopes back. It's kind of like slope staking an embankment, but it's just where does your ramp grade meet your existing terrain.
All the grade breaks within the PAR need to be perpendicular to the path of travel. So we've got to make sure that those grade breaks, if I'm coming into that intersection, into that landing, on my path of travel, the grade break is perpendicular to that path of travel. And to do that, and then also those ramps, to have those perpendicular grade breaks, my ramp lengths need to be the same on all aspects of that ramp. So I need to make sure in this case that I've got a 3-foot ramp that's 3 feet all the way across that ramp as we're measuring up and down there. So in this case here, we don't have a perpendicular grade break. My grade break should be right across in here, is where that grade break should be. So we want to make sure that those ramp lengths are all the same length. We want to make sure that our landings are all constructed properly. And what happens is that in this instance here, we would have ended up with this. Here's always the problem, okay? When we have nice square intersections in a residential neighborhood, we end up with nice landings that are all squares, right? And we're all engineers. We like to deal with squares. Sometimes we step outside of our comfort zone and we'll deal with a rectangle, okay? Now when we, okay, right? We've all built stormwater ponds that are all rectangles, right? Okay, now sometimes these landings are going to end up with being some odd shaped polygon, okay? In this instance here, here's my direction of travel, so my grade break has to be perpendicular to that path of travel, okay? Over here, here's my direction of travel, my grade break has to be perpendicular to that path of travel. So when you're working out all these different directions that you're coming and going off of your landing, that's where you end up with those perpendicular grade breaks and these odd shaped polygons as far as your landing. So that's why we need to clearly denote on our plan sets where those landings are at. And then that's also why we require that those landings be poured separate. So we're doing those initial landings at the top of those initial ramps, all being poured separate. So that way then we get those grade breaks properly constructed. So we started off doing this a few years ago. MnDOT started off doing this a few years ago with fan ramps only. When we switched to requiring that these fan ramp landings be poured separately, our initial compliance just jumped. Okay, we're tracking all those numbers and knowing it, and we went from struggling with compliance on those grade breaks to getting that compliance. on the majority of those ramps when they were first constructed. So MnDOT is requiring that those landings be poured separate. So I've heard the argument a lot of times from contractors, and they especially start to get into your guys' ears, and they start to tell people that, well, it's going to cost you more to do that because it's going to be another MOB charge. I've got to come in here another time. It's going to be another small load charge on your concrete coming into the job. And actually, we've actually had contractors that say no. I mean, and the ones that know what they're doing are doing this where they're pouring that landing at the same time that they're pouring the curb. So they're still there one time to pour. They're still getting one delivery for that concrete for that intersection. So it's not adding an additional cost for those mobilizations and for that concrete being delivered to your project. You end up with a much higher probability of having that constructed the first time as far as compliance goes. So it's on the standard plans now, so that these shall be cast separate. So that is clarified on there. So it's a key part that these shall be cast separate. Yes. On the flow line profiles, our preferred slope is between 1 and 1.5%. So whenever we're trying to shoot for flow line profiles, whenever we're trying to do our landing slopes, our cross slopes on our sidewalks, we're shooting for 1 to 1.5%. So the main reason that we're shooting for 1 to 1.5%, 2% is our max. So if you go above 1.5%, the contractor still has a 1/4 inch of deviation that they can be off. If you're off a 1/4 inch and you're at 1.5%, you're still going to be in compliance. If you design or you lay that out for 2% and all of a sudden you're off a 1/4 inch, you're going to be out of compliance. Okay, same way the other way of why we say 1% is our minimum. Okay, typically in our concrete world, we're going to say we want to have at least 0.5% flow. So we've got positive drainage coming out of there. But if you design again to that 0.5% slope and all of a sudden they're off a 1/4 inch, now you're dead flat. So that's why we are always trying to stick to 1 to 1.5% on those flow line grades across our PAR, on our cross slopes of our sidewalks, and on our landings. So we're always shooting for that 1 to 1.5%. And I realize, okay, that's not a lot of room for designers to work with. It's a lot of variation, right? 1 to 1.5%. But really we need to make up those grades in other places. And that's what we're going to talk through too, is the different tools that you can utilize outside of those key constrained areas. Does that answer your question? Okay. So when our boulevard is 4 foot or less, our curb tapers again need to make sure that they're matching that sidewalk profile. Because otherwise what we're going to end up with is negative drainage. So if I construct this right here, this curb taper to 6 inches, I'm going to end up with this curb being higher than my landing. So I'm going to be pushing water back onto my landing. Okay, it's not as noticeable when you've got a grass boulevard, but if this is all concrete boulevard, you're going to end up with an odd shaped piece to try and pour, and then it's going to be difficult to maintain. Your skid loader, your equipment's going to ride up on one piece and you're going to end up with a triangle in the middle of snow and ice that's not going to be removed. Sheet 2, and actually let's take a 15-minute break and come back at 10:25 and we'll talk through sheet 2. Things going, so that way we try and get done by the end of the day at 4:30. Oh. So we'll start off with sheet 2, and I'll just I'll tell everybody right up front is that just so if you're not in total panic situation, because it just took us an hour to get through sheet 1, it's not going to continue on that same pace, okay? So, because yeah, otherwise we'd be talking standard plans for the next 10 hours. So, sheet 2, again, this integral curb. We want to make sure that on that directional curb that's all constructed 2% in any direction. And we want to make sure that that's drained to flow. So we want to make sure that we've got that positive drainage going out of there, but we're still at that 2% max. Our walkable flares are going to be 8 to 10% slope. And this is a good one too, where we've got this 2-foot dome setback along here. This is a good example of depending on a different visually impaired user and what's going on with your sidewalk. On this particular example, they may be walking along the back of the curb or the back of the sidewalk as far as their queue. They may also be walking along this joint right here between the pavers and that par. The other aspect that they might be utilizing, if your boulevard is clear of any obstructions, they might be walking right along the back of the curb and utilizing that as their cue of where they're going up and down the roadway. So that's where we want to make sure that we've only got that 2-foot max dome setback. So if somebody's walking along the back of the walk here, they're not going to walk right out into the middle of our intersection. Sheet 3. So when we've got our positive flow drainage, we want to make sure that we're maintaining that 2% flow across our pedestrian access route. Again, we're shooting for 1 to 1.5% across those flow lines of our PAR, making sure that we've got positive drainage, but we're not exceeding that 2% max cross slope. We're also saying here that we've got, when we're transitioning our curb lines, so if we're in a perpendicular nature, we've got the perpendicular curb lines, our typical inslope on our curb and gutter is 6%. Okay, we need to flatten that out to 2 to 5% if we're in a perpendicular nature. If we're in the directional curb, the fans and stuff, that needs to go down to 2 to 3%. So we're saying that you need 5 to 10 feet of curb removal to transition from 6% down to 4% as you're going through your returns. Okay, the other part of this is that if we're doing tabling, we're going to talk through some different aspects and a little bit of tabling of our intersections to get that PAR at less than 2% going across our crosswalks, that we need to make sure that we have at least 10 feet or more of curb removal in order to get that tabling to occur. Okay, so if you utilize MnDOT's prosecutional work and our standard specifications, it is now in our standard specials that we've told our contractors, if our grades aren't working, you can just take an additional 10 feet of sidewalk or 10 feet of curb and gutter without telling us. Okay, because we're seeing it as just a problem across the board that we're always trying to set our construction limits too tight. So we just said if there's an issue, you can't make your grades work, take another 10 feet. We'll pay you for it. Don't come bother us because we know that it's an issue of getting those removal limits set. Outflow gutter is a detail that's shown on here. So outflow gutter is utilized when we've got vertically constrained points. So rather than our curb line, our gutter line coming down at 6%, we're now tipping that up at 5%. So that gains us 0.2 of elevation gain by doing that. So I'm not going to utilize this if I've got a block's worth of water coming around my intersection, my quadrant, I'm not going to use outflow gutter. But if I'm at a high point, I've got water going both directions, I'm going to put an outflow gutter any day of the week to get myself some additional vertically constrained areas. So it's a good tool to utilize if you've got that tight doorway or something that you're trying to tie into to get you a couple tenths. Want to make sure our max rollover is 13%. So if your slope of your ramp is coming down at 8, that we're only going up at 5. So talk about crosswalk running slopes. Crosswalk running slopes is the cross slope of our roadway. That should be 5% max. It's going to be that pedestrian access road as we're going across our roadway. So this is a new detail that's shown on here. And what this is our combined directional compound radius curve. It's going to help gain you some additional ramp length. So here is, let's see here. Here's our curve line. Okay. Here's our curve if we were to utilize a simple curve as we're coming through this intersection. Now if I utilize this line going around here with a simple curve, my ramps are going to start right here. This is going to be my ramp length. By utilizing a tangent, extending out that tangent, putting in a really tight radius here, a big sweeping curve through here, and a real tight radius up here, I've extended these ramps a couple of feet. So that's going to gain me a lot of elevation. So every foot of ramp that I gain, I'm gaining roughly an inch of vertical. So it helps with getting up a little bit higher. It also helps us to get 2 ramps in here. So if I was to, with this simple curve as we were in here before, I'm probably going to end up with a fan ramp in this particular instance. When I bump this curb line along these, extend those tangents out and put these curves in here, I'm going to end up with 2 separate ramps going through here. Okay, so a couple of benefits that we go through. And what we're talking about really is that we're going to put this tangent piece in the middle, this bigger curve, we're going to follow our truck movements as we're going around that corner. So you may even run your auto turn going around there and then back your curb line off to fit it. Now the other part is that I know this is a struggle. Okay, we want our radiuses to always be some nice even footage, right? I mean, that's, again, we'll go back to we're all engineers. Okay, I want to have a 3-foot radius going into a 20-foot radius going into a 3-foot radius. I want that math to work. Okay, I'm going to break it to you right now is that it doesn't matter. Okay, if you need to fit in a 2.8-foot radius or a 25.62 radius, doesn't matter. Okay, how's that contractor going to form up the back of the curb in the field? He's going to take a board and he's going to bend it around a couple of grade stakes out there, and that's what they're going to fit. So no matter how much time you spend trying to get those radiuses to work out to the exact even increment, it doesn't matter. So, sorry. So this is a good tool. It helps us to gain that additional ramp length and again to separate those ramps out too. It's especially critical. It helps us when we've got APS. So we get to get a little additional separation on those APS stations. So the next one, detail on there is going to be our ADA curb extensions with compound radius. Okay, it's a fancy name for a bump out. Okay, and what we're talking about here is really getting us 2 to 4 feet of bump out to gain some additional elevation in those vertically constrained areas. So again, an additional 4 foot of ramp is going to gain me 4 inches of vertical elevation. So it gets me a lot of benefit by just going out 2 to 4 feet and helping that instance. We want to make sure that we've got a 5-foot piece of tangent past our zeros, so that way there's actually, if you're a driver coming up there, you're going to see that curb line coming into that intersection. Otherwise you just have the ramp coming down and touching base and you won't have any sort of a vertical element along there. And again, it helps us to gain some space on our signalized intersections to get some APS push buttons in here. Okay, so this is on the ADA perspective. So let's step back for just a minute. Bump outs in general. Okay, what are some other benefits of putting a bump out in? Anybody? Traffic calming. Yep, that's a great instance. We always have on MnDOT projects, I'm sure you guys get it too. You've got trucks going too fast, cars that are going too fast. We start to pinch that driver in. We put some sort of a vertical element out there. We put our lights, we put our fire hydrants, we put a planter, some sort of aesthetic. That's a hard word for engineers to say too, aesthetics. But it starts to pinch that driver and slow them down. What else does it do? Yeah, shortens up my crossing distance. So we did a project, we had a 48-foot wide roadway, back of curb to back of curb. We shrunk it up, so that way it's still a trunk highway, so we had a 12-foot driving lane with a 4-foot shoulder. So that shrunk our crossing distance up to 32 feet. Okay, that's a 35%, 33% reduction in crossing distance. Doesn't matter to anybody here in this room probably. Makes a big difference to my 85-year-old grandmother. She does not move very fast. Okay, so you take that and you're really shortening up that distance from crossing the road. What else am I going to do with a bump out? It helps to separate that parking, for sure. Yeah, exactly. Enhance visibility. So 2 aspects of enhancing visibility. So if we're in a rural area, who always parks on the corner of an intersection? It's Farmer Joe with his big F-350, okay? I feel very comfortable with stepping out in front of that vehicle and making a decision if I can cross that roadway from standing in the pavement, okay? I have an 8-year-old and an 11-year-old at home. They're not allowed to make those same decisions and step out to see what's going on, okay? It also enhances my visibility of being able to be seen, okay? So now we take that F-350 out of there, and let's say we put a Toyota Prius on that corner, okay? My 8-year-old comes to about here, okay? It's about the same height as Todd sitting in his chair, okay? Still hidden behind that Toyota Prius sitting on the corner. So it's helping to see and to be seen, okay? What's my number one issue, my number one con for bump outs? Maintenance. Snow removal, maintenance, big pain in the butt, right? So the reason I'm having this conversation about all these benefits is because when we start to just do a 2 or 3 foot bump out from an ADA perspective, it doesn't get into some of these other things. You start doing a 4, 5, 6 foot bump out, you start to really make an impact as far as other pedestrian needs up and down a corridor. And you guys are going to be the first ones to have those conversations, okay? You might have the conversation with the maintenance folks as far as the benefits, and that, you know what, they might understand that, you know what, yeah, it's a pain to plow around. Every once in a while I'm going to hit the curb and I'm going to be mad. But if they see the benefit for their grandmother, their mother, their kids or grandkids, they start to understand why am I doing this and have a better perspective for it. The other part is that ultimately there's probably some decision maker that's going to be saying yes or no to these bump outs that's above yours and my level, okay? I always feel that it's my job to educate people, and it's ultimately your guys' jobs too, is to educate people on making those decisions. So giving them all the information to work through the pros and cons, so that way they make an informed decision as far as what the true ramifications of doing those things are, because it is always a balance. Okay, we've worked through a couple instances. In one particular instance, we put in some bump outs, and City Council was all on board with it. Public Works Director came around to it after a little while of convincing, of understanding all these benefits, but there was always this public perception of, well, how are we going to maneuver through the intersection? How is it truly going to work? Okay, we showed them how the auto turn was going to work. We showed them all the drawings, but in general, does the public believe a bunch of engineers with the drawings on paper? No, they start to question us. So took it another step further. We went out and we painted out these bump outs out in the field. Public Works put up cones. We had a local truck driver bring in his tractor trailer rig and maneuver through the intersection. And lo and behold, it worked just like we told them. But anybody have an idea of what the conversation was in the coffee house the next day? We hired too good of a truck driver to come in and maneuver through. So again, just to keep these all in perspective of what are some of the bump outs. So when we start to add these bump outs too, not only if we gain 2, 3 feet out into the roadway, are we gaining 2 or 3, 4 inches vertically, but oftentimes what we're seeing on our roadways is that, you know, the center 24 feet has got good 2% cross slope. When we start to get out into our shoulders, we're running 3, 4, 5, 7% cross slope on those areas. So you start chasing that grade in with a bump out, you're not just gaining additional ramp length, you're gaining elevation on your road. And you come in 3, 4 feet, oftentimes we're gaining 2, 3, 4 inches coming into the roadway on top of those ramp slopes. So it makes a big difference depending on your cross section.
You'd also want to make sure on a retrofit, if the bump outs get really large and you're going up a steep inslope, sometimes that curb line can even be higher than your sidewalk itself as you chase it up the inslope of the road. So just be aware of some of those geometrics that are happening with,
Right.
with the larger bump outs.
When you get into the big ones, yeah, you can run into problems. Another detail on here is this optional sill on the back of the curb. We've seen this both poured with the machine where they've got a piece that hooks on to the to pour it this way out of the machine, or we've just added on a piece of concrete onto the back of that, formed it up, and doweled into our existing curb and gutter there. but it works to help prevent where we've got this settlement of the sidewalk at the back of the curb and those trip hazards. Couple of pavement treatment options for you if you're utilizing ADA retrofit, a standalone project, or if you're going to be doing your ADA improvements several weeks ahead of when you're doing your mill and overlay of how to tie those back in together. But just a couple things that you can look at and utilize as you see fit. Sheet 4. Purpose of the domes is to inform the user that they're about to enter the roadway. Does this inform me that I'm entering the roadway? No, absolutely not. And you know, let's face it, I mean, this is what we were told for a number of years. There was some guidance out there that was telling us that we needed to provide directionality with those domes. Okay, the truth of the matter is those domes are there to inform the user that they're going to enter the roadway. If we can, we're going to line up our domes in a perpendicular nature, okay, and it's not for a visually impaired user. Okay, if we're trying to line those up in a perpendicular nature, it's actually for someone like Todd in a wheelchair that's going to be going down that ramp, and those wheels will actually go between the truncated domes and try and minimize the vibrations going up and down those domes. So, primary focus of the domes is to inform someone that they're going to enter the roadway. They do not point you. So along that, we've got to make sure that we've got our adjacent pavements at 8 to 10%. So those are a walkable surface in here, 8 to 10%. And our graded flares, when we're adjacent to that turf, those graded flares can be 1 to 6. Okay. When you've got a walkable surface coming in here, this needs to be a concrete flare. When you've got turf over here, there's no preference as to if this is a graded flare or a concrete flare. Okay, that's a maintenance item as far as a preference if you want a graded flare versus a concrete flare on those applications. So we want to make sure that all of our curbs must have that continuous detectable edge. So a curb is a detectable edge. That's going to tell me that I'm going to enter into my roadway. So as I come in here, I've got my curb. I come down to my 0. Within 3 inches of my 0, I'm going to have my truncated domes. Okay, then I've got my other 0. Then I'm going to have the curb taper on the other side. I'm going to taper up to at least a 3-inch minimum curb height. Okay, that's enough of a curb that we have a visual as you're going around that intersection. To do that, you're going to come up at 10%. So between these ramps, to get up to a 3-inch curb, you need a minimum of 5.5 feet between those two insides of the ramp. It's going to give you 2.5 feet at 10%, gets you up that 3 inches, 6 inches of 3-inch curb, and then come back down 2.5 feet at 10% to get to the other one. Okay, if we can, we'll go up to a 4-inch curb height in between our ramps. That's our preferred curb height. Okay, if you can get up to a 6, stay at a 4. Okay, the primary reason is that we don't go above a 4, because a lot of times what you're going to end up with is negative drainage going on here, because then your curb height is going to be higher than your landing here. So you're going to be pushing that water and everything back onto here. It's going to be a maintenance problem for you. So we're going to stick to that 4-inch is our preferred curb height.
So yeah, that's good to know that the difference between the zeros needs to be that 5.5 to 7 feet. But also we're looking to get 3-foot minimum ramp lengths on this. So it's those inside legs to be 3-foot minimum. And that's actually where, if you don't have that, that's where that compound radius we talked about earlier, that'll help bring that area out and give you more room to get 2 ramps in. It'll change it potentially from a fan ramp to 2 individual ramps. So that's one reason why we do a lot of curb line modifications of just only a foot or so will help you get that.
When we don't have curb and gutter, we want to make sure that our truncated domes are set back a foot from that bituminous, so that way then we have a 1-foot piece for visual contrast. So that way as you're coming across there, you've got your bituminous roadway, a foot of concrete, your domes, and then concrete behind there. So that way you can, a lot of visually impaired users are not going to be totally blind. So they're still going to be able to see some differences, so they'll see that visual contrast between the concrete and the domes to know that they're going to enter the road. what's wrong with my detectable edge? Say that again? It's not a foot back. Exactly. They need to be back. What else do I not have? Perfect. Yep. Not continuous and not a foot back. So we want to make sure that we've got those domes back a foot in this application and continuous along here. My grass is going to be detectable edge as we go around here too. Okay. The other point that I like to point out on this slide is this handhole right here. Okay. Great spot for this handhole in the boulevard. Okay. Not in the middle of our ramp. Okay. Ideally, we want those outside of our ramps and our landings, put them in the boulevard. Now, I also realize too is that on occasion you end up with that 4 foot by 6 foot by 8 foot deep electric vault that's located right on the corner, right? It's going to cost $20,000, $50,000 to move, okay? In those instances, we'll put the casting completely in the landing, okay? If we put it in the landing area, we can shim and adjust those castings to make them fit within the landing and get it to meet our relatively flat slope of less than 2% in the landing. I'll never put them in a ramp, okay? We haven't seen contractors that are able to shim those lids so that way they're at a sloped angle and make them fit within our ramps, okay? They definitely cannot be within our truncated domes, okay? It needs to be outside of our truncated domes, outside of our ramps, and if it's in the landing, it needs to be completely in the landing. Okay, you can't have it partially in the landing and partially in your ramp, because then you're not going to get your grade break constructed properly. Seen a couple big contractors over the years, haven't seen one big enough that can take that casting and bend it over his knee to get that to kink right. So if you need to put them in your areas, put them in the landings, make them fit in there. Otherwise, you're going to end up with compliance problems. Approach nose details, we want to make sure that we've got 3 foot tapers on our both sides in our direction of traffic, and then 2 foot tapers as we're going through our medians. Also in this example here, we've got a piece of V-curb in the middle here. Now in this instance here, our crosswalk is kinked. Okay, so that V-curb is going to help a visually impaired user know that they need to change direction as they're going across this intersection. Okay. However, if you're in a rural area and you need to know how this thing is going to be maintained, because if it's just going to be maintained by the plow truck driver dropping his wing down and going across this, a V-curb is not going to be maintained. Okay, so then we'd put a concrete flare on that, a taper, so that way then that could be pushed off with that wing of the snowplow. So understanding how these things are going to be maintained is key to know how those treatments are going to occur. The other aspect is if I'm in a rural area, it snows, we do get it cleared out of here. It's going to blow 12 hours later and then it's going to drift shut. So again, we want to make sure how these things are going to be maintained, because if they're not being maintained, then they're not going to be utilized 5 months out of the year. Crosswalks of going across railroad tracks, so we want to make sure that our domes are set back 12 to 15 feet from the nearest rail. Okay, that's a MnDOT is utilizing 12 to 15 feet. If you look at ProWag is going to utilize 6 to 15 feet. 12 foot comes out of the AREMA standards, out of the freight rail guidance, saying that we don't want anybody within 12 feet. It's our understanding that probably that difference is looking at light rail setbacks. So, you know, I sure wouldn't want to be 6 feet away from a freight train going 50 miles an hour. So think about this too, is make sure that you're measuring perpendicular from the nearest rail, okay? If I'm crossing at 90 degrees from my railroad tracks, it's really easy to measure my 12 to 15 feet. I look at where my signal pole is at. If I've got a gate arm, I check where my counterweight's going to come, so that way I'm not standing right where that counterweight's going to come up and hit me. But if I'm at an angle at a skew, I want to make sure that I'm measuring from that nearest rail over. Because if I go in my path of travel, I might be 15 feet back from that nearest rail. But as I measure over this way, I'm 6 feet. And again, think about this from a visually impaired user. I hear the train coming. I stop on my truncated domes and I think I'm perfectly safe. Now I've got a freight train going 50 miles an hour, 6 feet away, hoping that there's not some sort of an overhanging load on that train. So we want to make sure that we're measuring from that nearest rail to those setbacks. Sheet 5. We're going to utilize V-curb adjacent to buildings, so when we're putting in some of these corners, when we're lowering that sidewalk adjacent to those old foundations, we'll put the V-curb up against the building. It's just a 4-inch wide V-curb with the joint on the back. I'm trying to pour most of this integral so that way we don't end up with those secondary joints out in front. We've got 2 different types of V-curb shown on there. So number 1 is our preference, and actually that's where we've got our V-curb outside of our sidewalk line. So as I'm walking down my sidewalk, my V-curb bumps out on the back side of that, and that's a nice smooth taper. Okay, less chance of me, if I'm in a wheelchair, to go up and onto that V-curb. If you have to bring that V-curb into the sidewalk line, we still need to make sure that we have our 4-foot par going through there. But then that's a different taper coming up on the V-curb. It's going to come up quick, so that way I'm notified right away that, hey, back up, don't continue down this and end up with your left wheel higher than your right wheel. You're coming down here. We will utilize that, when we've got a tight vertically horizontal spot where we've got either right of way that we can't get and put that V-curb out beyond the sidewalk line. In this case, we've got that fence post that's in the way, and we've got a building, then we'll put that V-curb into the sidewalk line. Couple details here, one with the signal pedestal and one with the push button. So when we've got the signal pedestal, we're going to bump our V-curb out around that pedestal base. Okay? When we're utilizing our APS push button station, then that V-curb is just going to widen out itself and include the mount for the pedestal base. So that pedestal base is a 9x9, our 9-inch diameter as we go around here. So we've just poured our V-curb out with this knob, so that way then that push button station is just mounted into the top of my V-curb. Transition panels, okay? MnDOT is putting in all of our transition panels on our projects. When you're coming across, we've constructed new sidewalk at 1.5%, and we're having to tie into something that's greater than that. So in this particular instance, we've got 4.5% cross slope on our sidewalk. Okay, we have 2 options. Either we put in a transition panel, so we blend this back together, or we put in a 2-inch trip hazard. We're opting to put in the transition panel. So the key part here is that we want to make sure that we're taking out 0.5% cross slope for every running foot on our transition panel. So I've got 3% difference in my cross slope here. I'm going to end up with a 6-foot long transition panel. So the other part that I want to remind everybody here in this room, MnDOT's putting in transition panels. Okay, if your project comes up into one of ours, make sure to remove this transition panel. We've seen it in a number of locations where we've done nice ramps. We've put in a couple pieces of sidewalk. We put in a transition panel. A local agency comes up, does a sidewalk project, puts in new sidewalk at 1.5% cross slope, and we're always so hesitant to tear out a new piece of sidewalk. So we put in a transition panel of our own. Okay, so we've got nice sidewalk, and 10 feet of sidewalk that goes up to 4.5% cross slope. So make sure to pull that piece out. Check what you're tying into as far as cross slope, and maybe remove one piece of new sidewalk to get to that good cross slope. Otherwise, we've just created a barrier up and down that sidewalk with having that one piece in the middle there. Sheet 6. Sheet 6 shows our new landings with the reinforcing bars, those tie bars between the landings and the ramps and the sidewalks. So it's showing those details. If you're utilizing the MnDOT specs, special provisions, we're paying for drilling and grouting and reinforcing bars by the each. And those are all epoxy coated. We've also got the drilling and grouting on the curb and gutter retrofits too on that reinforcing. These details here show where we've no longer put expansion material at the back of the curb. All the expansion material is occurring back here at our tangents is where our expansion material is occurring. And we've got two different details for how we're reinforcing this and how we're tying this together. In this particular instance here on the right, we're tying those rebars, utilizing those bars into the curb and gutter. Okay, we'll utilize that instance if we've got a bituminous roadway and you've got a settlement prone area where you're concerned that your sidewalk is going to settle out from the back of the curb. But if that's a concrete roadway, we're not going to have a reinforced concrete roadway tied into the curb and gutter, tied into our ped ramps, tied into our landings all the way back. So we said that's too much, then we would still just stick with the one on the left in a concrete roadway scenario. Tabling. So when we've got greater than 2% slope on our flow line coming around, we need to table those out as we're going across our pedestrian access route. We're going to table those 2% max or up to a 4% change. And we'll walk through a couple of examples of where we'll go greater than 4%, but really that seems to be about the max that we can table things is about 4%. And we're showing here is that we're going to, when we're tabling this, we're going to blend our bituminous out through our parking areas, through our shoulders. We're not going to blend that through our driving lanes on this. So we still want to make sure that we're maintaining that through traffic flow, the rideability on that through traffic. Now, if this is a stop sign here and I'm stopping traffic, I'll blend this all the way out to the center line. Because if I'm tabling this and I'm blending this through here, if this is a stop condition, the driver, the rider is not going to feel that as they're going through there at a low speed. So when you've got those low speed conditions, you've got a stop condition, don't be afraid to table or blend that out further out into your roadway. So we've also got some example profiles in here. So in this particular instance, we'll change up to 2%. We'll come across our ramp at 2% max. Ideally, we're at 1 to 1.5% going across here. When we've got two ramps, we talked about a lot of the benefits. One of the things is too is that we've got the ability to dump grade between those ramps. So we can go 1.5% across here, dump grade between my ramps, and this is my secondary ramp on my curb profile. If we're in a fan, we come in, we're tabling this, changing grade up here, and then we've got a long area all the way across that fan ramp that is now tabled at 1 to 1.5%. So you lose the ability to help drop grade as you're going around to return with a fan ramp versus if you have two separate ramps going around there. We'll do the same thing with tabling, only we'll raise intersections a lot, and we'll talk through a lot of scoping of where we've done that in a number of applications. But really in this instance here, we raised this curb line 4 inches. When you raise a curb line and you're giving the contractor a profile elevation for that new curb line, and you've gone up 4 inches, make sure to clearly put that on your plans. Here's the new elevation with a note right behind it. Raise curb 4 inches. Otherwise, you've got a lot of potential for that to not occur. Okay. First one is your surveyor goes out there and stakes it. He's got his head turned on straight, and he looks at your stake and he goes, well, geez, Joe must not have known what he was doing. Let's adjust this grade down for him 4 inches. So he pounds the stake down, makes that grade adjustment, and you've just lost that 4-inch gain that you want. Or the contractor does the same thing because they think, well, this isn't matching my existing bituminous if I'm doing a mill and overlay. So making sure that if you are doing some sort of a raise, to clearly define with your notes of what you're wanting to do with those. If you're wanting to raise 4 inches, that you raise it 4 inches. So in this particular instance here, we did have a real tight vertically constrained doorway back here. And so we raised this, put in a new high point, and then we were able to, put our 1 to 1.5% across our pedestrian access route and then dump grade coming around the intersection. Same way over here, we had our high point. We'll go around 5% going around this intersection, get to our par, 1 to 1.5%, and then dump grade going into this instance. Now sometimes we'll add catch basins on both sides so that way you can artificially put in that high point in that intersection and catch the water on both sides. So it's a good way to bring your curb line up by just adding a drainage structure.
You know, if we weren't going to raise this curb line, there was no way you were going to get your ramp grades to work tying into that doorway, because that's a fixed situation. So that's why we're raising the curb line. And these types of modifications, especially when you got doorways, tie-ins, things like that, it's much easier to raise these curbs on a mill and overlay type project, just because you're paving in your new bituminous. And again, these shoulder slopes are often fairly steep, so you're not always doing a 4-inch intersection raise, but just correcting a steep shoulder slope is quite common. You know, so you can do this on a standalone, but it'll take a lot of patching. So to even thinking about how you program projects is important, because ADA will let you do, you know, either ahead of or concurrent with a preservation, like an overlay project. So these tricky ones, it's definitely better to do them with overlays, because you can have more freedom to change some of your constraints. This would be harder on a standalone. Standalones might be better in like a residential neighborhood where you're not tied into anything, and you can have, they're a lot simpler type ramps. So keep that in mind when you're programming fixes.
Those mill and overlays give us a lot of flexibility, and just because you're doing a mill and overlay and not a reconstruct, we'll show a number of examples of how we almost ended up with a reconstruction project for sidewalk and ADA perspective on a mill and overlay project. Because we can make some of these grade adjustments like this. We're raising a curb line 2, 3, 4 inches, and then doing more of a fill than a mill and fill type of scenario. Or like Todd said, is a lot of times those center line profiles will still match, but we're taking care of some of the grades in the shoulders and the cross slopes of the road. So we're now going to talk about driveways and sidewalk details. So on our driveways, our preference for our driveway slope aprons are going to be 8%. We'll go up to 10% on commercials and 12% on residential driveways. Those are our maximums. We still want to maintain our 5-foot par as we're going through those driveways. If we have a vertically constrained point, we will neck that down to a 4-foot par going through here. And again, we want to make sure that that par is 2% max cross slope. So we're always shooting for 1.5% in design for that cross slope of the par, even going through a driveway. And our sidewalk profiles, 5% max. So as we're going up and down our sidewalks, we want that profile to be 5% max, unless our roadway is steeper than 5%. If my roadway is at 6% or 7%, my sidewalk profile is going to match that grade. But if it's at 4%, my sidewalk can't exceed 5%.
Why do you limit the grade rates to 5% max after you get out of the truncated zone area? I think like in the city of Mound, where you have a lot of rolling hills, that could be a problem. You want to start breaking your road grade right away, which could be at 8, 10, 15%.
Yeah, and if you're at those extreme cases where you're at 8% or more, I think you're going to have a hard time, and we're going to show a couple examples where we might not table this all the way out to 2%. If your slope is really steep coming around here, we're only going to change this 4% slope coming around here, because otherwise we start to end up with, we're doing too much, and we'll show you a couple examples. But on this particular, if you were chasing this and you made this work with your road, and then you were dumping this at 8%, there's a lot of situations that I would do that, especially if we've got a stop condition. And I'll show you one too this afternoon where we did that in Rushford, where we tabled off our intersection and brought it over at 2%, and then we tied in at 6, 8% going down our roadway, but it was a stop condition there too. So I think some of that depends on what your traffic flow is going through here, on how hard to push that turnover, if you will, on that grade break. So.
And these are just general guidelines, you know, just it'll keep you out of trouble, but you can steepen like that 5% up. The ones you really don't want to mess with is the cross slope in front of the curb ramps, and also the roadway cross slopes of 1% minimum to get the drainage into your gutter, and 5% maximum on your roadway slope. Those are the true ADA type criteria. So your cross slope works, you have drainage, and your curb ramps work.
Yeah. And that's, I should have pointed this out too earlier, is that, there's a number of things that we're talking through, and, as a city or county person, you might be, well, why would I do that? Why don't I just do, I can still make this fit with my mins and maxes. And a lot of what we're sharing with you today is, you guys have all seen it, where we've gone in and we've done ramps and then we've tore them out and done them again, is basically please learn from our mistakes. You don't need to create them on your own, and learn from them. MnDOT's been doing this for a number of years. We've done things, we've had things that haven't worked out the greatest. And so from the local side of things, utilize our best practices so that way you don't have to learn from the same items that we've learned from over the last several years. So, driveways, again, so we're at perpendicular driveways, so we've got several types of driveways that we're going to utilize. Perpendiculars are our best type of driveway. We've got plenty of apron, we've got plenty of boulevard here to get our grades up to our pedestrian access route through our sidewalk. Ideally, that apron is still at 8%, but we're keeping our consistent sidewalk profile going up and down our roadway. Now, when we don't have enough boulevard to get our grade up to our sidewalk profile, we're going to steepen up this apron as much as possible, and then we're going to come and put our par in here. And so we've got to make an adjustment to our sidewalk profile as we're going down here. So similar to our our tiered curb ramps, we're going to do tiered driveways. So you're going to change your sidewalk profile and go down at a flat slope, go through your driveway, and then come up at a flat slope at those 2 to 5% changes. We don't want to have steep slopes on that sidewalk profile. Again, that's a usability issue. Plus, then if you go with a steep ramp, then you've got to have a landing at the top of those. Plus, we want to just keep our sidewalk profile less than 5% as we're going up and down our corridor. When we've got that sidewalk at the back of the curb, sometimes what we'll do is we'll offset our sidewalk to get through those driveways. So we'll taper that sidewalk back. Ideally, we're doing a 1 to 5 taper because we want a nice gradual transition that if I'm walking down the sidewalk, it's very easy for me to walk back and forth as I'm going through that driveway. If you've got a very abrupt taper, chances are your pedestrians are just going to walk straight through that driveway. And we'll also offset and adjust grade. So that way you help on both aspects. You gain a little bit of apron and you're going to lower your sidewalk profile. Parallel driveways are going to be utilized when we've got negative slope off the back. They're also going to be utilized whenever we've got sidewalk at back of curb. Okay? Whenever we've got those instances, we're going to use our driveway type 2 curb and gutter. So that's now got a 1-inch bump with a 1-inch taper off of it. So that way then we're maintaining that drainage out in the roadway. We're also trying to minimize how much we're going up and down with our sidewalk profile. So if I'm going along my sidewalk profile, I'm at 6-inch curb height, and now all of a sudden I've got to go down on my driveway to a 2-inch. I'm going down 4 inches on my sidewalk profile, and then I'm having to come back up 4 inches. So that's why we're trying to minimize that roller coaster effect. Now the other thing is that if you've got a driveway 50 feet, another driveway 70 feet, another driveway, kind of repeating all the way up and down your corridor, think about utilizing a 4-inch curb versus a 6-inch curb. So if you change that to a 4-inch curb versus that 6-inch, then you're only going up and down 2 inches on your sidewalk profile as you're going up and down this corridor. So just something to think about, that if you've got continuous driveways and you've got sidewalk at the back of the curb, switching to a 4-inch curb height is going to help minimize that roller coaster as we're going up and down our sidewalk. Sometimes we'll utilize a valley gutter to create more of that bump to get that vertical elevation as we're going through here. So it's another detail that you can utilize to gain some elevation. Sheet 2. So if you do a project for MnDOT, if we've got pedestrian access routes that are going through the driveway, we require that you put a driveway table in your plan set. So the driveway table is going to tell us, as we start from the left, it's going to tell us our station and our side. So it's going to tell us where the driveway is at, what type of driveway you're going to construct, and then what type of curb you're going to be utilizing. If you're going to be using our standard driveway curb, driveway 2 or driveway 3. And then it's going to tell us all of our elevations and our slopes across our driveway. So it's going to clearly define where my pedestrian access route is. It's clearly going to show what my apron slopes are. So it's a good tool for the contractor and construction staff to know what your plan was, what your intention was on those driveways going through the project. And these are our driveway curb and gutter standards. So our preference is the top one, the driveway curb standard. And that's what we should be utilizing on all of our areas, especially if we have parking adjacent to the roadway. So even though a driveway is not constructed to an ADA standard, that's still an access point. So if we don't have a bump there, that's very easy for someone to park on the roadway, utilize that driveway to get up onto our sidewalk and traverse the sidewalk. So we want to try and preference is our driveway standard curb. If we've got those parallel ramps, parallel driveways, or we're trying to reduce that roller coaster effect, we're going to use our driveway type 2. So that's got the 1-inch bump and then the 1-inch taper. On very rare occasions where we've got a garage door or something right at the right-of-way line, we'll use driveway type 3. And that 3 is a 1.5-inch bump with then a 1.5-inch taper. So that's a really big bump if somebody's having to navigate that with a car. Ideally, we're just going to say get some additional temporary easement and go back onto private property with tying in that driveway and those vertically constrained points. But if you've got that garage that's up against the right-of-way line, then we'll utilize the type 3. Sidewalk transitions. So we're no longer putting in expansion between our sidewalks and our driveways. We're now putting in tapers on the thicknesses for that sidewalk. So we're going from our 4-inch sidewalk and matching our driveway thickness. So if you've got a 6-inch driveway, you're going to have that transition panel that's going to go from your 4-inch walk to your 6-inch driveway concrete thickness. So we're no longer putting that expansion in there. So this is some examples of where we've got the wraparounds in the driveways where we're wrapping that curb around. Okay, and the top ones, these are true barriers. Okay, we've got this curb that's coming all the way around here through our pedestrian access route on both of those. So we've got a true vertical element that's inhibiting my access up and down the par. Now in the bottom two, I've still got, maybe I have 4 foot through here. I've got 4 foot through this one. But if I'm walking up and down this sidewalk and you're walking shoulder to shoulder with somebody, that's a pretty good trip hazard for somebody that's on the closest to the roadside there too. So ideally, we've got those tapers and not wrapping that curb as we're going around those intersections.
And you also got to think about it from a visually impaired user standpoint. You don't want any trip hazards where a pedestrian could be walking. So these return curbs, even if they aren't in the par, they are also a trip hazard. All 4 of these are examples of trip hazards. So at MnDOT, we use all flares on our driveways when we have a walkable surface. So I know there's a lot of details like this where it's always a return curb if it's a walkable surface or grass. I mean, in grass, it's okay if it ends at the sidewalk, but we wouldn't recommend these in any walkable area.
Same way when we're going through, here, obvious, our pedestrian access route should be back here adjacent to the building, and that's right where they've got their tables and chairs and everything else set up. So now I'm having to navigate down the sidewalk out towards the back of the curb, and then I'm having to follow that back of curb line around on my driveway, because otherwise I come out here and I've got a trip hazard and everything else, and then come back here. So it's just, again, those graded flares, those tapers are going to blend through so that way they're a walkable surface and not a trip hazard. The concrete flare, sorry. Yep. Sheet 4. Want to make sure when we're adjacent to buildings that we've got that positive drainage coming away from the building. And earlier I mentioned we've got 5 foot as our standard sidewalk. When we're adjacent to a building or a continuous vertical element like a retaining wall, okay, we're going to want a 6 foot minimum par to provide for that 1 foot shy distance away from that building or that structure. So we want that 6 foot par. We're going to put any sort of pavers, stamped concrete, those architectural features out in our boulevards. We want those clear out of our pedestrian access route. So that's going to provide a lot of excessive vibrations as we're going through here. Okay, when our sidewalk is meeting up with the doorway or a step, we need to make sure that we're providing for that landing out in front of that doorway or that step. So if something's coming onto the right-of-way, we've got a door that's entering onto the right-of-way, we need to make sure that we have that landing zone out in front of that door. So this is really where Title II meets Title III, you know, your right-of-way requirements versus your building code requirements. So this is building code pushed out into the right-of-way so that way we have access into those buildings. So this is showing us an example of that. So in each of these doorways, front of these doorways, we've got those landing areas. Our sidewalk profile is max 5% coming down here. Our boulevard slopes, ideally our boulevard slopes are 1 to 5% across the majority of our block. That's where we want those to be. If we've got a vertically constrained point for a short area, we'll go up to 8% on those boulevard slopes. But think about this, if you're parking on this street, you're stepping up a 6-inch curb. If you're stepping onto something that's greater than 5%, that's a very awkward step. You know, plus if you've got pavers or stamped concrete in there, those are going to be prone to being full of ice and snow. You've got the real good possibility of a fall right there. So again, those bricks, pavers, excessive jointing, good spots for those in the boulevard, we keep those out of our pedestrian access route. So those are going to be rolling resistance. So if you ever have an opportunity, hop in a chair, go down some pavers. There's a lot more push to going up and down those. They're trip hazards. They're also going to cause a lot of painful vibrations for some spinal cord injuries. And also we've got those maintenance issues. So whether it's snow and ice or something else, or the pavers just heaving over time, they are going to be those issues. One thing that we're requiring for MnDOT is we're telling them to make sure that the landscaping plans have been reviewed by the ADA staff, or make sure that your engineering department looks at those prior to rolling them out to the public. So we've had a number of instances where some of those stamped concretes, those pavers are shown within our pedestrian access route. We show those to the general public, and lo and behold, that's what they prefer, and then we have to take a step back and say, no, we're not going to do those particular instances. So here's a good example. We've got our clear pedestrian access route. We've got our street furniture. We've got those pavers in the boulevard outside of that clear par. Any questions?
We'll keep recording here for a minute. I like to kind of throw in some points here from a personal perspective. First, being on the pavers. Those, like Tim was talking about, there's definitely rolling resistance in there, but also there's a lot of, like I have a spinal cord injury, so my nervous system is really hypersensitive to my level of injury. So just going over those little bumps, which wouldn't be that big of a deal to you, a lot of you folks in a chair, it can really set off really sharp electrical shocks with me and my legs. So just wheeling down there is just, firing off like you're getting the shock treatment. So believe me, don't like those pavers. I personally don't. But there's also, even when you have excessive jointing, a large project got done in the metro probably 20 years ago where they had the window pane jointing, 2x2s with excessive joints and whatnot. The week it opened, many people in wheelchairs did not like that. They thought that was the worst idea ever. It looked great on paper. The business community liked it, but really tough on wheelchairs with just the vibrations and the extra wheeling and all that. So again, it's still out there. It's been 20 years later. If I was bouncing along that corridor for 20 years, I would get really frustrated, more so than just when I'm visiting an area. So that can really make a difference. So at MnDOT, we've always required that our spec book for years has required it to be a tight joint, 1/4-inch radius. Contractors have not been building those very often. They've been going to these really big joints. So we've went to saw cuts. Whenever it's more than a 50-foot sidewalk replacement, we're doing saw cuts. And if you're ever walking around and you ever see like cigarette butts sitting in a joint, definitely doesn't meet standards. It's way too big, so you don't want that to happen. Also, cross slope. Tim talked about that quite a bit, and I'm in a manual chair, so how it affects me is, you know, if it's 2%, it's pretty good. That's relatively flat. As it starts to get steeper, as the cross slope gets steeper, you know, if I've got my road over here, my curb over here, and my doorways here, gravity is just going to naturally take me towards the street. My front two wheels are going to go towards the street with that. So, and actually as that slope gets steeper yet, then, you know, I have to push harder with this hand just to correct. And if that slope gets to be even steeper and steeper, I have to push harder with my left hand, but there's a point where I can't just push hard enough with my left. I have to actually pull backwards with my right hand to correct. So I'm trying to go down the sidewalk just like all you guys, and I'm wheeling forward, but I'm pulling backwards with one hand, so very counterproductive. And as that slope gets to be real steep, you know, this arm just starts to wear out. So I do 2 or 3 blocks of that, and this arm's getting wore out, starting to fire. So generally all I have to do is cross the other side of the street, go down the other sidewalk, because it's probably built just as poorly, and I can work on this shoulder. So cross slope is huge. And especially when you're going up an incline. You know, I get the fact that I've got to go up this 6 or 8% hill. There's nothing anyone can do about that. That's just what it is. But again, as I go up that 8% hill, it's a lot of work. And then I start throwing that another cross slope against it. It's like twice as hard. It's magnified. It's just those 2 double vectors working against you. So there's a point where you just can't push anymore with that downhill hand. So it becomes a real barrier. And I've got pretty good strength, but you know, I'm getting older, and there's other people that don't have as good a strength as me, so they hit those barriers earlier, that point where you just can't get up. And actually, that's why we're tabling a lot of our flow lines in front of our curb ramps, because you know, we've got this 6 to 8% ramp slope. But again, if I'm doing that with a 4% cross slope, it's much harder. But if I do my curb ramps at that less than 2% cross slope and that running slope, it's much more navigable. So that's a lot of my personal experience, but even on cross slopes, I was out doing a field walk with a fellow employee, and it was a long one. We were out there for a good part of a day, and I was wheeling along, and I was tired, you know, just from fighting the cross slope and the bumps, but he had a fused ankle. So when he was walking on that same cross slope, his ankle didn't bend, so his knee kind of just bent inward and was grating the whole way. So he was in real pain at the end of that walk, and he said no sidewalk should ever be over 2% from his standpoint. And again, those with balance issues, walkers, you know, it all helps to have that be that flat type of surface. So, yeah. Any questions on any parts of that? Okay. Well, great. Well, I think we'll call that good for that module, and we'll move on to APS.